Hello everyone, my name is Ritik Manghani and today I'll be walking you through Milestone 6, Advanced ETL Orchestration and Comprehensive Security Framework for AetherMart Data Platform. This milestone is about moving from simple ETL script to a production grade data ecosystem with reliability, governance, and enterprise security. AetherMart's data has grown significantly. Customers, products, orders, and reviews are being generated across multiple systems. To support analytics and AI, we need a pipeline that doesn't just load data. It needs to validate it, govern it, protect it, and monitor it. Milestone 6 is where we bring all of that together. So, the agenda for today is an architectural overview, advanced ETL orchestration, error handling and monitoring, data governance principles, end-to-end security and the mitigations, business impact and metrics, and finally the AI usage reflection. This is the end-to-end architecture overview. Let's break this down. We start with raw CSV files for the datasets. We then enter the staging layer where the basic structure checks happen. Then comes the validation layer, which enforces strict rules like valid emails, proper dates, rating ranges, and PII checks. Then we have the transformational layer, which cleans and standardizes the data. Finally, everything lands in the production schema of the data warehouse. Around these layers, we have metadata and lineage tracking, full audit logging, role-based access security, monitoring and retry mechanisms, and finally we have the analytics and AI. This layered approach ensures trust, reliability, and traceability. Moving on. So before diving into the pipeline, let's clarify ETL orchestration means coordinating multiple datasets in the correct order, handling dependencies, retries, errors, and logging, similar to how an air traffic controller manages incoming and outgoing flights. It ensures that each step runs at the right time, in the right sequence, and under the right conditions. Uh, so when I say pipeline is designed as a DAG or directed acyclic graph, it simply means that tasks are run in a specific direction. Tasks cannot loop or repeat indefinitely. Each task depends on the previous one. For example, you cannot load orders into production without validating that customers exist. This structured flow prevents data corruption and ensures consistent, predictable execution. So, this is the pipeline flow that we'll be following. Uh, CSV files, initial data from products, customers, orders, and review will then enter the staging tables. Initial load and validation will happen in the staging tables. Then we transform and validate the data. The Python ETL logic for cleansing, standardization, and filtering is performed. Then we all load it into the production tables with the 7 primary tables and the constraints. So our DAG style automated flow covers all 7 datasets with clear task dependencies, ensuring parent tables load before the children, like I previously mentioned, that it will follow a proper flow. The system is idempotent with an auto truncate feature for safe reruns and efficient batch processing, ready for large datasets and future distributed deployments. So we also made the pipeline idempotent. That means that you can run the pipeline as many times as needed, and each run produces the same result without creating duplicates. This is achieved using an auto truncate mechanism that safely clears production tables before reload. This is essential for real world pipelines that may rerun due to failures or updates. So I'll quickly take you to the code base that we are following. Uh, here we have the orchestration framework, and we have even included the task's execution status. So I want to mention here that all the code that I have used, all the scripts that I have used is generated using Claude AI, and it was trained multiple times, and I was involved in all the debugging process through the entire end-to-end application. So this is the log that we have, and it is going to retry multiple times, like I told in the orchestration pipeline PPT slide. So and also it will have an audit logger to check which helps in debugging stuff. So we have integrated the ETL pipeline here, what we previously performed, and we have even added the memory usage part of it. Then there's schema creation to just cross verify all the tables are there. Then there's the creation of staging tables, and then executing the schemas. So this is the truncate production tables that I just mentioned for idempotency, which will help prevent duplications. And so this is the first stage where we load into the staging tables, and then there's the transformation part. Then we are loading it into production. And this is the main orchestration. This will help identify that whatever we have done is already there, and it at the same time the code is written in such a way that it will help debug at any step. If at any step it fails, it will help identify what exactly went wrong. So when I run this program, when I run the script, so we see that the categories table in which had 10 rows have loaded 10 rows. The suppliers have that had 40 have been loaded. The products have been loaded. Similarly, order items have been loaded. And for the reviews, 36 were valid, so those have been loaded, and the invalid ones have not been loaded. They have been stored into the quarantine tables. So the final execution summary, duration it took was 0.71 seconds. The entire status is success. Tasks failed 0 because the loading happened, and this was stored in the invalid, so it's all fine. And task successful 19. The pipeline completed successfully. And now if I want to check the audit logs, I can, I'll quickly open up this. So this is the README document that I've prepared to help anyone facing the issues. This involves all the debugging steps that uh, for all the processes where I got stuck. So this entire document has the entire debugging steps as well. So coming to the audit tables, so I created the audit tables. I'll just quickly show what the audit tables look like. I'll change the TV. So we have these four log tables, of which we just created the pipeline and the task right now. So this table has all the execution ID, run ID, pipeline name, start time, end time, status, duration, tasks executed, successful, failed, and the execution log has the task ID, run ID, task name, start time, end time, etc. So I'll quickly go back. This entire document, like I previously mentioned, has all the steps that I had performed, like right from creating the to activating the right from activating the virtual environment to installing the connector, etc., and the file structure how it should be. So uh, I have everything in my virtual environment, and all my data is in the data folder of the virtual environment, and the environment variables were also set, and these are all the dependencies that I had installed while running it. This is the entire code that we just saw on the instance that I ran. It's a pretty big code. So, yeah. So monitoring the execution, the pipeline will output detailed logs to the console. So we just connected these. We saw that, and now we'll be checking the execution summary. So this is from the pipeline execution log. As you can see that uh, all the statuses are in success except for the testing one, the test 123, and the task successfuls were 19 like we had previously checked, and the tasks failed were 0. Similarly, if we have to view the view all tasks for the latest run, so this is all the data corresponding to the to all the tasks that were just run. And if we have to view all the failed tasks, we do have the code. And to check the log files, etc., we have, and this all has the data. I have added the snippets too, for helping identify what exactly needs to be done. Right. So first we check the data quality, and then so customers with email were 89, customers without email were 11 in the total customers. And then we check the transform data uh, for the reviews as well. Total reviews are 36, valid ratings were 36, average rating was 2.944. And then we even perform the task performance uh, process. For we perform performance analysis basically. So this helped us get the analysis of task type, executions, average duration, min duration, max duration, and total records, etc. Uh, the success rate by task was also given. So it was 100 rows, and the 50 rows for the production, and the staging was 100, and loading as well. So check pipeline execution that we did we just perform that, and we did check the log files, right? So, and we even went through the orchestrated pipeline. So if we go through the pipeline, schema was created, then truncate production tables for the idempotency, then load staging categories, load production categories, and like I mentioned that it will continuously retry it if any part fails. So it tried in the first, like I have given like 4 attempts, so it was successful in the first attempt. So attempt 1 of 4. So the number of attempts were 4, so that it doesn't go on like for indefinite times. Okay, so task transform customers, load production customers, load staging products, load production products, load staging orders, etc. Like you get the gist. Okay, so moving on, I'll go back to the slideshow. Uh, Distributed execution and EC2 nodes. This pipeline is also architected for distributed execution across multiple EC2 instances. Uh, so why does this matter? It's because at AetherMart scales, uh, different nodes can handle, because as AetherMart scales, different nodes can handle different tasks, improving throughput and resilience. A centralized audit database keeps track of task status, so all nodes stay in sync even when running independently. So we have the multi-node design. Pipeline is designed to operate across multiple EC2 instances, independent execution units with shared audit log, cross-node consistency, idempotent loads ensure consistency across nodes, health and failover node health checks conceptually supported failover workflow. If a node fails, tasks retry on alternate node. Scalability benefits horizontal scaling for increased throughput, load distribution across compute resources. Reliability and error handling. So real world data pipelines fail, network issues, bad files, slow disk, etc. It's normal. That's why we implemented exponential backoff retries, like 5 seconds, 10 seconds, 20 seconds. This prevents overload and allows transient errors to resolve. Then we have a quarantine layer. Bad data never goes downstream. Invalid rows are moved into a dedicated quarantine table with an error message, like we saw for the 14 rows that we found were invalid. Logging at 3 levels. So we have console logs, real-time file logs for debugging, and database logs for compliance and auditing. With this, we gain visibility into pipeline stages, performance failures, and overall health. So zero data loss because all 699 rows are accounted for, either successful loaded or meticulously logged as invalid. Moving on, uh, our logging stack has 3 layers: console logs, info level, file logs, debug level for detailed task diagnosis, diagnostics, and database audit logs for pipeline execution log plus task execution log that we just saw on the instance. From uh, these meet the robust monitoring across distributed components aspect for MariaDB for AetherMart. Our comprehensive audit logging schema includes pipeline execution log that in, that is used for tracking overall status and duration, and task execution log for detailing task performance, records processed, errors, and retries. Tracks uh, task duration. Monitoring tracks task duration, memory usage, and performance queries for continuous optimization. Moving on to the data governance principles. Data governance is the discipline of ensuring data quality, integrity, consistency, and accountability. It answers key questions like: is the data valid? Where did it come from? Has it been transformed? Who can access it? Are we protecting sensitive fields, etc.? So we have data quality, data consistency, data lineage, metadata management, PII governance, accountability, and auditability. So governance has been applied to all four data sets. Customers table, RFC standard email validation, uh, and the null checks were done, PII classification, sensitive fields cleaned and restricted. For orders, date formats are standardized, non-negative amount checks, uh, that the values are the amount is non-negative, foreign key validations, etc. And for reviews, ratings must be between 1 and 5. 14 invalid rows were logged and quarantined. Prevent biased or corrupted sentiment data. And for products, we use the type enforcement schema standardized fields. These rules ensure the warehouse receives clean, accurate, analytics ready data. So PII is personal identifiable information, must be handled with extreme care. Our, so customer email addresses, identified PII in our system is like customer email addresses, physical addresses, and full names are sensitive PII. Staging filter, invalid PII are like malformed emails, which we saw were quarantined and prevented from reaching production. And logging sanitization, no PII is written to pipeline logs. This helps in mitigating exposure outside the secure database environment. And then the RBAC, role-based access control enforcement. This helps to access. This helps access to prevent PII columns, which is strictly restricted based on the user's defined business role, adhering to principle of least privilege. So in our system, we have implemented six functional roles or six RBACs. So there's this DBA role access that we have given to David Miller. He has the full admin access and will help in database administration. Then we have the CTO role for Alex Kim. This is just the read only all access, etc. And product manager, similarly we have product manager for Sarah Chen, marketing for Maria Rodriguez, data analyst for John Analyst, ETL service for full CRUD, etc. So the key security principles here are separation of duties, need to know basis, least privilege access, no shared accounts, role based, not user based permissions. So if we come back to the instance, I have implemented this uh, access, and we will quickly check. Yeah. So here we check that the product manager Sarah has, has PII protection. She can view products, can view orders, but is blocked from customer email, blocked from customer location, and can use privacy preserving view, and is blocked from inserting. Similarly, Maria from marketing can view customer email, can view location, can use marketing view, but is blocked from inserting. Data analyst John has column level security, can view allowed columns, blocked from email column, blocked from location columns, but can use analytics view. And similarly, CTO can has only read only access, but is blocked from insert and drop. DBA David has all the access, has full administrative access. So PM, so this is these are the detailed results, and the RBAC testing summary for our uh, implementation on AetherMart project. So we performed 22 tests and all of them passed. So we have a success rate of 100%. This is the detailed result snippet. Metadata management. Okay, so uh, field types and constraints defined for every table, PII flags for sensitive data identification, standardized documentation across all data sets, end-to-end lineage tracking. So we start with CSV, then we proceed to staging, then to validation, transformation, production, and then analytics. The business value enables regulatory compliance and audit reconstruction, facilitates troubleshooting and root cause analysis, supports impact analysis for schema changes, provides transparency for customers. Moving on to the security aspect. Uh, in the security assessment, we identify vulnerabilities like exposed PII, over permissioned users, misconfigured security groups, SQL injection, unencrypted connections, weak instance credentials, sensitive data in logs. So for this, we have documented mitigation strategies like strong IAM policies, identify access manager, sanitized logs, parameterized queries, encrypted transport, network firewalls, like we have been using the security group, the firewall for our instances, and key rotation like Dr. G had mentioned. So we can encrypt the key. This transformation helps the pipeline to become more secure, enterprise ready, and basically enterprise ready environment. So the enterprise data architecture, we have data sources, which can be from multiple sources like external systems, ESVs, multi-channel platform, multiple ingestion points basically. Then we have the staging layer, raw ingestion and initial data capture, invalid data isolation, validation layer, PII checks and format validation, rule-based quality filters, transformation layer, data cleaning, mapping and enrichment, business logic application. For production layer, we have trusted relational data for analytics, MariaDB persistent storage, governance layer, lineage tracking and metadata management like we just saw, ownership and PII controls, security layer, VPC isolation, virtual private cloud isolation and IAM policies, uh, in identify access manager. So RBAC and encryption at rest or in transit, monitoring and audit, comprehensive logs and metrics, audit tables and performance queries, analytics and AI, BI dashboards and reporting, semantic search and personalization. So this is the end-to-end enterprise data architecture. So this is an executive summary and key achievements. Milestone 6 unifies orchestration, governance and security to deliver reliable, trusted data for AetherMart e-commerce platform. So we saw the advanced ETL orchestration, implemented an advanced framework with exponential backoff retry logic for robust data flow. Then we looked into comprehensive security, designed and deployed role-based access control, achieving 100% success rate in PII protection test. All 22 of them passed, right? And efficiency and governance reduced processing time from 2 hours to 4.1 minutes, and implemented column level security with privacy preserving views. Audit and compliance, established a complete audit trial uh, for audit trail for compliance and operational insight, ensuring full data traceability. So the business impact here is, for leadership, higher data trust, better strategic decisions, PII compliance strengthened, readiness for audits and regulators, risk mitigation and governance. For engineering, uh, we have a clear pipeline visibility and observability, faster troubleshooting and debugging, robust architecture for scale, reduced operational overhead. For data science or AI, clean, consistent customer and product data sets, validated reviews for NLP models, strong foundation for personalization and recommendation, reliable data for machine learning pipelines. So AI usage reflection, balancing automation with human expertise. Uh, so for this project, AI helped in documentation structure, code refinement, and rapid prototyping and boilerplate generation. Uh, I had to look over what the data was, what the output was, and continuously fix whatever uh, Claude gave me. I had to debug the entire code. Had to apply where and all I was getting stuck, and to look at certain documentations and then referring to the perusal documents and asking to reiterate whatever the requirements were. The key learning for this was AI accelerates the development but doesn't replace human understanding. The best results come from AI human collaboration. Uh, that's all from my side for the Milestone 6 project, and hope you learned like I learned from this entire project, and hope you found it insightful. Feel free to share your thoughts and have a great day. Thank you.